Today's lesson covers pages 8 and 9 in our textbook. Lesson 3, Common Algebraic Expressions. So we'll have a lot of practice evaluating algebraic expressions today. And what is an algebraic expression? It's a combination of constants, variables, using addition, subtraction, multiplication, and division. But we can also have exponents, roots, square roots, cube roots, or even absolute value in an algebraic expression. When we're asked to evaluate an algebraic expression, we fall back on using PEMDAS, right? What's inside parentheses first, then exponents, then any multiplication or division, and then addition, subtraction. Exercise number 1 asks us to consider the algebraic expression 4x squared plus 1 and to state the operations occurring within the expression in correct order. Well, 4x squared plus 1, well, we have this exponent of 2, so that would be done first. So x would be squared. Next, we have 4 times x squared, so multiplication would be next. And then lastly, the plus 1 addition. Evaluate the expression for the replacement of x equals -3. We'll put -3 in place of x. So this is 4 times -3 squared plus 1. -3 squared is +9 times 4 is 36 plus 1 is 37. Exercise number 2 asks us to consider the more complex algebraic expression, also known as a rational expression, because it is in the form of a fraction, 4x plus 3 divided by x cubed minus 7. We want to simplify this expression for when x equals 3. Substitute 3 in for x. We have 4 times 3 plus 3 divided by 3 raised to the power of 3 minus 7. So since this is a fraction, what we do is we simplify the numerator and then we simplify the denominator. And then we divide the 2. Okay, so simplifying the numerator, 4 times 3 is 12, and 12 plus 3 is 15. And simplifying the denominator, 3 to the third is 3 times 3 times 3, which is 27, minus 7 is 20. So 15 over 20, 15 divided by 20 actually reduces to, dividing each numerator and denominator by 5, reduces to 3 over 4, or the decimal equivalent 0.75. B asks us if a student entered the following into the calculator, it would not give them the correct answer. Why or why not? Rather, why not? Well, let's see. The calculator would follow the order of operations. So in this sense here, we have multiplication, looking at this. Then we then have addition. We have division here. Oh, we have the power, so this would be done first. And then we have subtraction. All right, so 3 raised to the third is 27. Then we would have the multiplication, 4 times 3 is 12, plus 3 divided by 27 minus 7. And then the calculator would do this division. And 3 divided by 27 is simply the fraction 1/9. So 12 plus 1/9 minus 7 is not going to result in our 3/4. This is more like 5 and 1/9. And the reason why is because in order for it to be keyed into the calculator correctly to give the correct outcome of 3/4, this would have to be put in parentheses. That represents the numerator, right? That's what we have here. That's our numerator. And then our denominator, this here would have to be placed in parentheses. That is our denominator. In exercise 3, here we're asked to evaluate two expressions in which we have absolute value. It says the absolute value expression, x minus 8 plus 2, is it equivalent to the absolute value of x plus 10? Check this by choosing and substituting in a value for x. So I'm going to say let x equal 4. Right? So the absolute value of 4 minus 8 plus 2. 4 subtract 8 is negative 4. The absolute value is actually a distance. A number is from 0 on the number line. So if I look at negative 4 on the number line, how far is it from 0? It is 1, 2, 3, 4 units away. So the absolute value of negative 4 is 4, and 4 plus 2 is 6. And if we take the absolute value of 4 plus 10, 4 plus 10 is 14. So these are not equal. 6 does not equal 14. They are not equivalent. In exercise number 4, we have an expression containing a square root. Evaluate the expression for negative 3. All right, so we were just replacing our x there with negative 3, so it's the square root of 25 minus negative 3 squared. Exponents first. Negative 3 squared is 9, so the square root of 25 minus 9. And 25 subtract 9 is 16, and the square root of 16 is 4. B asks us, why can we not evaluate the expression for x equals 6? Well, let's see. Square root of 25 minus 6 squared. 6 squared is 36. 25 subtract 36 is negative 11. Oh. Because we cannot take the square root of a negative number. Doesn't exist. It's not real. For C, Max thinks the square root operation distributes over subtraction. In other words, he thinks he can take the square root of each term and believes the following equation is identity. So he's actually thinking that, oh, the square root of 25 minus x squared, he's thinking he can take the square root of 25 is 5 and the square root of x squared is x and say that it's equivalent to 5 minus x. We want to show it is not an identity by giving a counter example. So let's pick a value for x. I think I'll pick 9, or not 9, 3. I'm going to let x equal 3. The square root of 25 minus 3 squared. Does that equal 5 minus 3? 3 squared is 9. 25 minus 9 is 16. The square root of 16 is 4. 4 does not equal 2. So there's our counter example. Hopefully tomorrow we will look at their graphs on the graphing calculator. Okay, exercise number 5, we have a little more complicated expression. We've got a square root of the absolute value of x minus 8 is the numerator of our fraction underneath the square root, and the denominator is 5x squared plus 4. Which operation comes last in this expression? Well, this expression here, underneath the square root is this whole fraction. So we would end up simplifying the whole fraction first, and then the square root would be done last. Evaluate the expression for x equals 2. Square root of absolute value of 2 minus 8 divided by 5 times 2 squared plus 4. Okay, the numerator, 2 minus 8 is negative 6. Denominator of our fraction here, 2 squared is 4, times 5 is 20. The absolute value of negative 6 is 6 divided by 24. Square root of 6 divided by 24 reduces to 1/4. And the square root of 1/4 is 1/2. Exercise number 6, which of the following is the value of, and here we have the absolute value of the square root of 4x plus 9 minus x squared, all divided by 3, when x equals 10. Okay, so absolute value of square root of 4 times 10 plus 9 minus 10 squared. Close the absolute value, all divided by 3. Okay, underneath the square root, 4 times 10 is 40, plus 9 is 49. So I've got the absolute value of the square root of 49 minus 10 squared is 100. The square root of 49 is 7. Seven minus 100 is negative 93, but we're still in absolute value. And the absolute value of negative 93 is 93, divided by 3 is 31, which is option 1. Thank you very much for your attention. I hope you have a good remainder of the day.